Hello and welcome to MSB Technology, Audiophile Foundation. We're going to do a tour through our factory today. We're really excited to share a lot of the manufacturing and processes we have in-house and how they contribute to our product design and performance. This is my brother Jonathan Goldman. I'm Daniel, and we'll get started and do a walkthrough. Welcome.
So in the front here, we utilize like every square foot of our building. To your right, there's bookkeeping. In here is an engineering office. It's actually my office, as well as Dustin's, who you'll also meet. So in here, we do a lot of the electrical design work, actually all the electrical design work in here. So, we have all of our test tools, our prototyping station where we, tinker around. Over here, this is for programming our products, the parts. And, we have all kinds of really cool toys in here that we can go over later or now. We have, a 7.5-digit multimeter phase noise measurement system for clocks, a large screen oscilloscope, audio precision. We have our own audio precision in here and one for production. And then back there is all the tools we need for tinkering around and playing. So Dustin, who sits here, he does a lot of the audio design work, the analog and the DSP digital filtering design. I do like the user interface programming, USBs and renderers.
Yeah, and on the bench here, we have a prototype of the new Sentinel DAC that's coming together. And we'll get Dustin in here to talk about it a little bit and kind of something that a lot of people haven't seen or heard about, so exclusive to this tour. So Dustin, if you want to talk about this a little bit.
Okay, so this is an early prototype of the Sentinel DAC. And this is actually the technology that the Cascade is based off of. As I was developing this, sort of COVID rolled around and we had to sort of drop everything and manage part shortages and all sorts of crazy stuff. So it kind of got put on a shelf. But as soon as we were able to, I started developing for it again, and that resulted in the digital director and then the Cascade. So the concept of the Cascade and the Sentinel is that I wanted to completely divorce the audio processing from the actual conversion, okay? Because I found over the years that the small amount of electrical noise that's generated by the audio processing and the connection to the rest of the system can really have a detrimental effect on the sound quality. So the Sentinel and the Cascade, the concept is that the hardware in here is dedicated only to the actual conversion step. And the audio data is received through a fiber interconnect, okay? So the fiber interconnect has pre-formatted data that is ready to be converted in the DAC modules, sent over the fiber network, and then that's streamed directly to all of the modules simultaneously. And the Sentinel will contain a single fiber connector and 16 DAC modules. And this requires a rather high data rate. So there's a single chip in the middle, which takes a serial stream that was generated at the digital director end, and then directs that to each of the DAC modules in turn for conversion. 16 DAC modules is kind of overkill, which is the whole concept in the Sentinel. It reduces the output impedance of the DAC modules to around 16 ohms. And these DAC modules can reach a noise figure, if you know what that means, of around 1 dB, which means that the 16 ohms coming out of them has a noise floor that is only 1 dB higher than a 16 ohm passive resistor, if that makes sense. So extremely low noise. Yeah, so in order to fit it all in one chassis, this is going to be a conversion module that contains all 16 DAC modules. It contains the local regulation that's required for all of the hardware inside each DAC module. And then in a second layer, it contains all the volume control and all the control over the analog signal that's necessary, like phase inversion and so on and so forth. And so it'll require 2 fiber connectors.
The analog stuff is on the bottom.
Yeah, so the DAC modules have this data flow. The data flows into this end of the dump modules. The conversion is done by the hardware on the module. It then flows out of a connector on this side of the module, which flows to the bottom board. And the bottom board then does all of the analog functions that are necessary and will have the jacks on it. Now this is a prototype, so it's not going to be precisely like this in the final version, but it'll be similar.
And then that's one channel, that's the other channel.
Yeah, so this is, I don't know, what is it? The left. And the other one's the right. Yeah.
So do you have to apply gain after the deck?
With this much power available, no. I mean, so much power is available, you go ahead and plug in planar magnetics right to the output of this, and it'll drive them perfectly. You don't need any power gain after this much. Yeah, so the next part of the Sentinel project, that's the DAC portion, is are the new clock modules. So these have been difficult, but I've finally gotten the design just honed in perfectly. So these clock modules are significantly bigger than our current femto clocks. They have much more expensive and much better quartz crystals in them, as well as incredible oscillation circuitry. And these are significantly better than our femto clocks, which were already like almost world leading in their phase noise generation. But they're rather large, and they consume a lot of power. So there's 2 of these.
Are they heated or something?
Yeah.
Temperature controlled? Or?
Right. So there's 2 temperature controls in it. There's a temperature control that controls the overall case temperature, and then a temperature control for the quartz crystal, known as a double oven system. Okay. And yeah, these are incredible. So the quartz crystal companies, when I was asking them for particular crystals for this, the designers had some ideas, and they offered to send me some crystal designs which were not available anywhere that they were liking to make, as long as I would share my phase noise measurements with them, and they were shocked at how low a phase noise I was able to get.
Yeah, the performance of this clock and our measurement system exceeded that of the company that manufactures the actual crystals.
So, so these will be ready for the Sentinel as well. So so the Cascade is the mini version of the Sentinel using our previous amazing femto clock technology, and the Sentinel will have this new clock technology inside of it. So the clock circuitry in the Sentinel basically will be generated by two of these. They have to be on a vibration isolation platform because even tiny amounts of vibration corrupt the phase noise of the clocks. That will be then sent to the clock distribution circuitry right here, which in order to keep super low phase noise actually has like dedicated channels for each of the DACs running from the clock distribution out to each DAC individually. And that's the basic layout of the new Sentinel.
You can show them the scale difference. There's a Femto 33 up there, Dustin, on the shelf.
Sure. Yeah. So here's the Femto 33, which again, it contains two ovens inside, but it is not a double oven system. It's just a single oven. Each quartz crystal is ovenized, and it has ultra low phase noise oscillators and a switch to switch between the two for the conversion family of 44.1 and multiples thereof and 48K and multiples thereof. Okay, and that's the Sentinel.
Yeah. So we'll head to the listening room, show you that area as well. It's a very tight layout in the factory since California and real estate being what it is. But we own this building, so we're able to modify it and build on it in any way we want. So this sound room was one of those projects where we were able to tear out the ceiling, tear out the walls, and put in a room within a room. So this is a completely independent structure from the rest of the building. Jonathan can talk a little bit more about the construction of the room, but we have custom power run here with transformers for isolation. We have dirty power for testing. We've done a lot of work to make this more of a lab listening room, but we do not do sales at our factory. We do not do sales here. So we don't bring people here to show them our products. That's for our dealers and distributors to do. But like this is for testing purposes.
This is an R&D room for us.
So it's not the coziest room you've seen, but it's effective and it's very good for listening and evaluating differences in electronics, which is the most important for us. If we had made this the perfect room with the perfect power, and we made our product work, and we shipped it out to someone who doesn't have that in their system, they're at a disadvantage because it's having an expectation to have a room set up a certain way. So we have different power inputs so that we can evaluate, just dirty power. We have 300 solar panels on the roof, all the inverters and noise, and we have CNC machines, SMT lines. So the dirty power is very dirty, but we need to be able to evaluate transformer noise and all of these different aspects and how they interact with our products so that when we ship, we're confident in its performance in a regular system.
Yeah, because if you have perfect power with no noise on it, you can't tell what improvements your power supply designs have or your part selection. Do the transformers hum? Do they make noise? Or how good are they at rejecting AC mains noise? So we have power isolation. It's not perfect power in any way, shape, or form, but we have the various options. We have 120, we have 240, we have non-isolated, and we have 3 phases in the building. But as Dana was saying, this room construction, it's a room inside a room. So the exterior is a shell that is sealed for air. Then there's fiberglass insulation for sound absorption. But this room here is a freestanding structure. It does not tie to the outside of the building in any way. It's only connected, obviously, on the floor where it's sitting. There's actually a gap between this wall and the exterior wall on the outside. And then this is actually 2 layers of 5/8 drywall plus a layer of plywood with green glue for vibration and absorption. So it is a studio level soundproof room. It's a soundproof door on special hinges that raise the door when you open it. And then behind the curtain here is a soundproof slider door to the outside. We did that for 2 reasons. 1, listening. We don't want to hear the parking lot and road noise. And 2, when people are listening, we can still work. So it's a combination of both. the AC duct is all run through duct silencers, so this room is actually very quiet when you sit in here with the door closed and nothing playing.
Resting on a concrete slab?
Yes.
Yes, it is a concrete slab. That is a harder thing to change if you wanted to change it. We actually hired a local Bay Area acoustical designer who designed the acoustics for the room. We picked the dimensions. This is the largest we could fit in the building without actually needing to remove the roof. Ideally, we'd go another foot or two taller, but we had to work within the constraints that we had. So, but we've been very happy with it, and it's been a great R&D tool for us to use. And it's very convenient being right attached to our office.
So I'm surprised to see the high gauge of speaker wire you're using.
Yes, so we don't have any audiophile brand cables in here. Everything we've made ourselves, and again, this is an R&D facility. So we do everything ourselves. We have different cables and bins with different impedances to see what impact that has. But there's no brands on any of our cables. They're all made by us.
So this is your favorite cable for the speakers as far as you know?
I mean, there's other cables that I'm sure are better.
Yeah.
This is what we use because we have these speakers now. We also have Magico M2s, S3s. We have some homemade. We cycle speakers out. New product development, new amp development. We're not listening to one pair. We don't do development with one speaker. We do it with as wide of a range of speakers as we can get in the building. And then, when we have some people come, they bring bags of cables if they want to play around with it. The other thing we do is there's other people that have different systems, like we'll drive it up to Tony at his showroom and we'll take it up there and listen there, or we'll take it other places as well when doing development.
Yeah, we really want the cables and their characteristics to get out of the way for testing. And what we're focused on is mostly A/B progression, where we've got one product and we're trying to improve it in a certain way. So we want to hear those differences. So we need the most revealing system possible for that. And so we're going to have you guys listen all afternoon, but what you're going to be listening to is the Cascade DAC. So this is our new DAC that we're just now getting our production caught up since its release. This on top is the digital director. So this handles all the digital processing, all the digital noise. And I think its power is actually plugged into a separate outlet that's on its own circuit. So you'll see that if you look around the cables back here. In the middle here is the analog converter. So this is, again, where all the DAC modules are and the preamp. And then this here is a dedicated power supply for the analog converter. So all analog supplies in there, very low noise. And this is the power supply that has more of the critical power to be looking out for. And then this will be paired with the M500 amplifiers that we make here as well. We might be able to show you inside those as we go through the factory tour. So full MSB system paired with the Estalon Forzas. That'll be later in the tour. So let's go ahead and head back to the front door, and then we'll continue through the building. All right, so next up is my office in here. So we can go ahead and come on in, and I'll show you some of the things we do here. So at MSB, we have a really big emphasis on doing things ourselves. We're a small company, and we like to do fun projects and fun work and learn new things. So we do all of our in-house photography and videography here. So a lot of our tutorial stuff we'll film in this area with the system as a sample. We do our product photography on this table here. We have the backdrops, all the lighting. It's a fun thing for us to do. We enjoy it, and so, we do it. And so this is Kevin's desk where he does all of our website, post-processing of photos and videos. Behind you here is where Sondriel does our CNC programming. And then my desk is here in the corner where I do all the CAD design. So Sondriel and I work together a lot on the design and the machining to improve how the product is made. With in-house design and manufacturing, you can really marry the design to the tools you're using to make them very efficient. So a lot of companies will design a product and they will send it to a shop and say, make this thing that I've designed. And it might be more expensive or more difficult or not as good of a product because you don't know what machines they're using to make that product. So this is one of those unique things where, like, I'm working on the mechanical design and then I talk to electrical and we say, well, you know, we could maybe add some more board space here and add some more circuitry in this area, but maybe we could move another dimension here. And so we have a very back and forth design with all of our products, and we, you know, start with a prototype, do a complete revision, usually another prototype, and then final revisions. And really, like if you look inside the Cascade, you're going to see many boards layered on top of each other in really cool three-dimensional layouts that you just don't see in most companies. Most companies, you've got a big empty box with a big board and a lot of open space. But we like very efficient products. We like efficient design. And so everything is very compact and very well engineered as a full system. So we'll show you some of that later in the tour.
And one last thing, we're both amateur woodworkers, hobbyists, and Daniel made his own desk and made the desk in here.
Yeah.
Because walnut's our favorite wood species and had to have our own custom-made desk.
We do as much as we can in-house.
When we say we make everything ourselves, including our desk. So.
So we can.
All right, this is our production room. The reason we bought this building was this room. It's gigantic and it's beautiful and stunning and has this old truss system that we really loved. This used to be a Chevy dealership, car dealership, so the whole front of the building used to open up and just be a big open showroom. We, of course, have filled every corner and are bursting at the seams for more space. But these production benches are where we're assembling all of the mechanical and electrical systems together. So this is final assembly. There's inspections happening. If we come closer to the bench, I'll show you a little bit of what it looks like when a product's going together. So behind each station, we have the product associated with that build. So we do a lot of lean manufacturing practices here. We don't like people running around or having to find components and parts. So this is like a power base station. This is the power base. All the hardware is here. You can reach up and grab what you need when you need it. All of our drivers are all torque drivers with torque settings, descriptions on there of what to be using them for. So we're not over tightening devices or straining hardware when we do our builds. So you can hear those clicks as it hits the correct torque. And in the inventory shelves, we're pulling those circuit boards out, installing them, transformers, and all the pieces. We have documentation on everything, but we do build enough of these that we don't usually have to consult it. But we do have that in place when we're doing onboarding and training of new employees. And then all of our products are submitted to multiple inspections before covers go on. Even in our circuit boards, we'll have little cutouts with viewports underneath the board. So if a device is mounted with thermal paste, I need to be able to look through the viewport in the circuit board and make sure thermal paste was applied to that device. So we've done a lot to make inspections easier to do so that they actually get done. And if you come this way to our inventory, so being a small company, it's controlling inventory is always a big nightmare. But we subscribe to the method of Kanban, which is basically a mechanical inventory system. So there is no digital inventory. We do not keep track of any Excel sheets. We do not have anyone coming out writing down numbers. We use Kanban. So Kanban is basically very simple. You have your Kanban bins, which is your reserve. So we want a reserve that's big enough to get to last us through a new production. And then you have your inventory. So you use up your inventory, you hit Kanban, and on these bins, we have a QR code. So the first item that gets pulled out of Kanban, you scan it with your phone, it sends an email to our purchaser, we start a new production, the Kanban lasts long enough for the new production to come in, we continue to use the Kanban, so old stock is used first, and then refresh it. So there's no time wasted. There's no issues. We don't ever show up and be like, oh, we ran out of a part, because we have these mechanical systems that are much more infallible compared to software. If I'm sitting at my desk looking at an Excel sheet that says I have 100 of these, and I walk out and I don't, it doesn't matter if the Excel sheet says that. This is one of those times where, as a small business, it's really important to be very lean, and especially trying to compete in California, where labor is so expensive, you can't have people wasting hours every week on stuff as frivolous as inventory management.
Well, and the other thing is, since our products are all modular, it's not like we use them in a 1-to-1-to-1 ratio. One board might be used in 2 or 3 different products. So, instead of trying to keep track of, oh, we sold this DAC, now we need to subtract 2, and we sold this one, we need to subtract 4, the Kanban just takes care of that automatically. Whereas, if everything was built 1-to-1-to-1, well, then it's much easier to keep track. But we don't build 1-to-1. Our hybrid DAC modules go in multiple products. Our prime DAC modules go in multiple products. The input modules on the other side here, they go in all the products. So it's one of the things that the physical implementation, it eliminated all of our crises of, we don't have this, because something was forgotten. So,
yep. And on the benches, you'll see some Cascade analog converters. I asked you to refrain from taking up-close photos, if you would. But you can go ahead and look around those and see kind of the layout. This is one of the 3 chassis in the Cascade. So over here is going to be our shipping department. So this is shipping and testing. So you can make your way this way. So this is our test station. It looks messy, but it is very effective. We have the audio precision up top. We have DACs and sources set up for every type of format, every type of interface, so that we can test everything very thoroughly in a very real-world application, because that becomes very important, especially if we're testing new products, new implementations. So everything goes through some very thorough testing. So you'll see here, this is not a finished product, but it is at our test station. It is getting a full AP test. Everything in there is being tested through hundreds of tests run on the audio precision. It is not finished. We do this for every subassembly. That is why we do modular design. Everything needs to be rigorously tested. And we test them as subassemblies before they ever go together, because we never want to build a product, test it, and have it be close to being perfect, and be put under the pressure to make a decision of whether or not we ship it. We want everything we ship to be perfect. We have very high standards. So we test it when it's easy to repair, it's easy to replace parts that are bad. All of our DAC modules have to be measured even before they go into cases. So like a DAC module gets measured, I think, 5 times before it ever leaves the building.
Yeah, it gets measured when it comes off the production line. It gets measured after it goes into the case. It gets measured in the subassembly. It gets measured, as a final set, and then it gets measured again before it goes to the shipping inspection bench. So everything is measured just...
Every manufactured unit.
What was that?
Every manufactured unit.
Yeah. Yep. So everything gets measured multiple times. And the main reason for that is, it's not like we're finding errors. Finding errors is incredibly rare. We're doing it because we want to make sure, beyond a shadow of a doubt, there are no errors before it goes out. When it comes to repairs, we do them personally. We don't assign somebody to do the repairs, because we have influence over the manufacturing and the design of our products. So if we see something we're not happy with, if something fails, we have the power to change the design or the process to prevent it from ever happening again. And we've been doing this long enough now that, this product, its repairs have been basically non-existent. We have experimented with burning in, running overnight tests. They have never shown a failure. So,
Yeah.
we do run it and let the products get warm, but it's not like we go, oh, let's give it a 24-hour runtime. Because what we have found is, through our measurements and our audio precision, is our standards are set so tight that our 2 audio precisions have greater variation between this unit and the unit in there than this DAC to the next DAC. So we literally have to adapt our measurements for each audio precision because the two have a greater variation than every cascade we've ever produced. So, if there's something wrong, if there's a cold solder joint, if there's anything going on, it shows up in our measurements because, as Daniel said, we do like hundreds of different parameters on every DAC numerous times.
Yeah.
So
components that fail, they fail very fast. And the danger is if you put covers on things and you test it for 5 minutes and send it out, something could have failed and you might not have picked up on it. But like we do these tests beforehand, right? We give a lot of exposure with the open circuit boards to see if there's anything causing issue, anything that's like, if a capacitor was backwards and it was over voltage or something, like we can catch those errors much earlier in the process than later. Even still, all of our circuit boards go through inspection systems that you'll see later in our circuit board manufacturing that catch any of those mechanical problems. So like we don't have a lot of product making it to this stage that has like fundamental mechanical assembly issues. So it's really more about the performance than it is about catching issues at this point in the process. All right, and then behind you is shipping. So we have these great lights, very bright, full spectrum, really high quality. This is basically, we want to have the most revealing light and station to inspect product. We want it to show up at a customer's home and them to not even be able to see what we saw when it left. We've gone through an evolution where at this point we have very high standards with our finishes, and it's really awesome to be able to ship those kind of qualities. These new cascades are manufactured on our new Grobe CNC, and the finish and fit of everything is just very, very tight. So very high standards, great lighting. We do a white glove inspection of every product. On each product there is a signed inspection for testing and for finish. So I can ship product with confidence and not have to worry about it when it arrives. And then here's our accessory boxes for the Cascade, where everything gets inspected to make sure we have all the components included. And we switched to this kind of method where there's pockets for everything. So if you're missing something, it becomes very clear it's not there.
And Daniel does the inspections personally for product.
Yeah, I inspect every product personally. So it does slow things down if I go on vacation, but there'll just be a backlog and then we'll catch back up. All right, and then moving over here, we're going to be approaching the SMT circuit board manufacturing. And I will let Jonathan and Dustin both talk about what's going on here and give you the full tour. It is going to get tight as you go around the corner. So I don't know if everyone will be able to hear, but feel free to squeeze in and try to hear and see what you can. We'll come back with the camera and get maybe some better shots of the machines running, but I'll let him take over.
Yeah, so as he said, this is Dustin and I, this is kind of our domain. So all of this equipment has been picked by us. Most people would consider it vastly overkill for our volumes. But what we did is we picked the best of each piece of equipment. And the reason is that it's not for the speed, it's for the quality. So this here is, I'll just give you a quick overview and then we'll walk through and see it. This is our stencil machine. This is the only stencil machine we could find that has integrated full 3D inspection of the solder paste. We actually have boards running now, so you'll actually get to see a Cascade preamp board go through the production line and get finished. The next machine is our pick and place machine. It has 7 nozzles on it, so it can pick up 7 parts at a time, takes a picture of each one, inspects the component, places it, can place up to 19,000 parts an hour, which again is wildly fast for what we need. Then it goes to our vapor phase reflow oven and inspection, so I'll go over that more when we get back there. This is our drying cabinet. So as you can see, this is heated to 40 degrees C at 3% relative humidity. We dry all our components before we place them, and we dry the circuit boards before they go to the vapor phase reflow process. It's just something we do. Here in California, it's dry enough. You technically can get away without it, but we do everything we can to make sure we achieve the highest quality. So if we come through here, so Tim is the one that runs this equipment every day. He just loaded a board in right here. It's going through right now, and it's doing a scan of the board. Then it's going to print. And basically, a stencil machine is kind of like a t-shirt silk screener. It has a mask with holes in it. You squeeze solder paste, which is just balls of solder and flux through each aperture. Then it pulls the board down. Then it uses a LiDAR scanner to scan the board again, and it measures the volume of solder on every pad. You know, in all electronic assemblies, the vast majority of manufacturing errors can be traced to this process. So this is where we spend a lot of attention getting the inspection, because if we catch the error before the parts go on it, we don't have to repair it. You just wipe the paste off and print it again. So it's one of those things that we did. As you can, it just moved the squeegee across right now, so it just printed. Next it's going to go through and scan it. If there's errors, it brings them up and lets you review them. Sometimes there's just false calls, and we just say, yep, nope, that looks fine. But
One at a time?
it does one board at a time. So our throughput, depending on the board, this is not a limiting factor. That machine isn't. It's actually our reflow oven, depending on the board. Sometimes we're waiting for this. It depends on the complexity of the board, how big it is, and how many parts there are. So it is, now it's inspecting the board. And there were no errors, so it didn't pop up. If there's an error, it pops up with the screen, and it shows you an actual 3D measurement of every defect. And it lets you review them. And what you do is, if there's errors, you just say there's errors, you take the board, and you print it again. So you can see it came out here. So before this board went in, all these pads were gold. They now are gray, because the gray is the solder paste on each one. So, you know, the board comes in, it scans it, it measures the fiducials, it aligns it to the stencil, holds it up, puts the paste on it, pulls it down, scans it again to measure the volume, and it reports the actual volume of every pad on here. We couldn't find any other piece of equipment that did it all in one machine. Normally there was a pre-scan, a print, and a post-scan, and it's, you know, a big long conveyor line. Oh, and every board has a QR code on it for traceability. So after it prints, that paste is wet. So again, it's balls of solder in flux. Then the next step is it goes into this machine. So if we can move this way. So here it is. This is the pick and place machine. Each one of these feeders has a different part on it. These are resistors in tape. Each one of these holes is an individual component. So what it's doing right now is it's going through, it's picking up the components, it's taking a picture of every part to make sure it's there and aligned, then it's going and placing it onto the circuit board. So this board here is almost finished. The best build time is 4 minutes and 20 seconds for the board. So it should be done in about 18 seconds or so. And then when it comes out, you'll see it over here in just a quick human pre-inspection station. So the boards come out, we look at it before we reflow it to make sure everything looks aligned and correct.
And soldering.
It's placing the parts into the solder. So as you can see, here's the board. These parts are not secured to this board. If I took this board and I tapped it, they'd all fall off. It hasn't been soldered yet. So the parts are sitting on the solder paste. And then they go from here, we look and make sure that everything looks good, which it pretty much always is. And then it goes to this. This is new when we moved to this building. This machine here is really cool. It's called a vapor phase reflow oven. Most board shops do not use this technology. They use something similar to like what you would find in like a pizza shop. It's a big long conveyor passing a board through hot air being blown around. The downfall of those is A, it uses a ton of energy. But more importantly, in order to get all the parts hot enough to melt the solder, the small parts get way overheated. This is different. This machine here in the bottom is a pool of a product called Galden. It's completely harmless, it's non-toxic, but when its vapor is heavier than air, so it heats up the pool of Galden and creates like a steam bath. What it does is it takes the board, we load it into a tray. It's actually running right now. So if you look down there, you can see the boards sitting in the steam right now. And so what it does is the steam condenses on all the parts, and the bigger the part, the more the steam condenses on it because it takes longer to heat up. This process cannot overheat the components because the steam's at a fixed temperature. And obviously it's much easier to transfer heat with steam than it is with hot, dry air. It's also an oxygen inert environment because you've now lowered it into the steam of Galden. So that's why we don't need to feed like a nitrogen stream into it, because by default it's oxygen inert. This process is very common for like aerospace and space rated devices because it gives you much higher quality solder joints versus the hot air.
So the steam is hot enough to melt the solder?
Yes, the steam is, you literally order the Galden, the product's called Galden, you pick the temperature point you need. So if solder liquefies at one temperature, you pick slightly above it. But what that means is the steam cannot exceed the temperature of the material you ordered. So you can't, burn the parts or cause them to drift. Because if you overheat analog components, they can drift. This process, you're not overheating them. So they don't drift like you would in a conventional oven. It also has a bunch of thermocouples in there, so it's monitoring the temperature of the board. It's not time-based, it's temperature-based. So it knows the temperature of the board, it knows when the solder's getting close to hitting liquidus, then it melts the solder, holds it for a time we program in, then cools it off. It brings it up and circulates cold air over it. That's an air chiller up there. So it's a complete closed-loop system. It's not as fast as a conveyor belt system, but more importantly, it's really small. Our last oven was 16 feet long, drew 200 amps, 3-phase. It cost $20 just to turn the switch on it. This is like $3 a day in energy. So way more energy efficient, way more environmentally friendly, and the space savings is, it's amazing. Because the old one was 16 feet long, but you needed access to all 4 sides of it for service. Parts went in one side, they came out the other, and you had to do maintenance on the front and back of it. So.
How do you make sure, so you place the parts here, and they're still wet there. How do you make sure that you don't accidentally move them going from there to there?
So the paste is sticky.
Okay.
So if you take the board, this one I'm not going to do it because the relays are larger, but if it's just the small devices, you can actually hold the board upside down, and it's not coming off. But if you bump it, they'll break loose. So, we're obviously very careful when we transfer it. But after this, it goes to our inspection machine here. So this is the newest thing we have. This is made by a company in Korea. They're the world leader in, it's called AOI, Automated Optical Inspection. So in here is a super high resolution camera, and it has different colored lights that it flashes and takes pictures, and it prints patterns. It does a full 3D scan of the board, as well as it goes through and it can read every part number on every component. And it is so accurate, it can measure the coplanarity of the every part to make sure it's not tilted or tombstoned or skewed. I can actually show you here. We stick the board in. It goes through and it's taking pictures, and I'll stop it halfway through so you can see what it can do. It can also measure the curvature of the solder on every part. We find, and we do this real time as we build, because if this catches an error, we go, well, wait a minute, why did it catch an error? And so we'll actually go back and figure out what's happening. Is there not enough solder? Well, maybe that's this machine. Is there, parts are tombstoning, meaning one side melts and it picks up. Well, then we go, okay, it's this process, or maybe it's moisture. So instead of building all the product and then analyzing it, we analyze it as we build it. And this prevents pretty much every error here. So here's just a capacitor. It measured the cap. It checked to make sure it's not missing. It measures the size. As you can see, it's within 1% of where we programmed it. It checked to see, is the part sitting flat? So, it measures these 4 points, and you program in the amount of variation you allow. And then here, for the solder, as you can see, it actually creates a graph of the solder. If the solder did not bond to the part, it wouldn't be a sweep up. It would be a dome. So it's looking to see, is it a dome or is it a curve? And all of this is configurable. We build up the part library over time. It used to take me hours to program a board, but now that I've built the part library, I can program a board in like 20 minutes. And then it measures, is the part sitting square on the pad? Has it does it have drift? And we can go through, and it inspects every single part. So, here's another part. It measures each pin. It checks for the solder. It checks the tip of each pin to see, are they all in line with each other? If one pin is bent up, it'll flag it. It'll say, hey, wait a minute. These pins are all in line with each other, and this one's up slightly. Why is that? You would be surprised at how many parts come from the manufacturer directly with like a bent pin. And so this catches it. Obviously, you would catch it in testing, but we like to catch it before it even gets to testing. So, it's checking the pins. It's checking between the pins to make sure there's no solder shorts between it. It's checking to make sure the part's there. It's literally reading the number on it. So it's checking through and like, what's the number? It checks every parameter of it. When we do a build from year to year, sometimes I have to make adjustments because like the manufacturer, when I first programmed it, they did white printing. Now they did gray printing. So I had to change the parameters for that. But it just goes through and it checks everything. If there's an error, it'll flag it. And sometimes there's just false calls. So like right here, it says, hey, this pin's not aligned. For some reason, it thinks the pin is off in free space. So that's when a human looks at it and goes, no, that's actually correct. It sometimes struggles with very tall parts and very small pins. So this is the relay. So the part is very tall, the pin is very small because, again, the way it's measuring is it's not a LiDAR scanner. It's literally using optical images, and it's printing like grid patterns over it. So obviously, half the light is blocked by the part itself. So then it goes through. Each one has a QR code on it. So it is logged. Every board we have produced, I have high-res images of every part on the board in our database. The processing power in this thing rivals any other computer in the building by a very large margin. Because it's going through and it's analyzing 100,000 different parameters for each board in real time. So it's incredible what this machine can do.
How long did it take you to learn this?
A morning. Well, it's because like we had a previous inspection machine before this that I knew. This machine is just much, much higher end. Also, it helps if you understand the concept behind the program. Like I do programming, so I understand programmers, image recognition, contrast. Like when you understand the base technology, even before seeing this machine, I knew how it worked because I understand the fundamentals of it. So learning to do it was really easy. Now this machine has like 1,000 settings for each part. Some of the settings you don't need to touch unless, it's a complex part. Like on this screen, black parts on boards, it's really hard to see it, so you have to be very careful how you program it.
How many circuit boards does this make?
one circuit board every 5 minutes? Or?
Well, it depends on the board. So this is producing one board every 4.5 minutes for this product. Some boards have hundreds, like our display boards. I forget how many hundreds of resistors there are, and they're panelized. So there's actually thousands of LEDs on each display panel. Well, this takes like 45 minutes for that. But it's placing like 5,000 parts on the panel. So, and you know, we change how it places it, like LEDs, you have to place a little slower and be more careful than other components. So this is actually the oldest machine in the building. It's made in New York. They were actually like the first company to make this type of equipment. Their background was bending paper clips. They were approached to bend through-hole components. Then they started making machines to place through-hole components. And then as surface mount technology developed, they came out with this series. The company originally started with paper clips. They were bending wires. So.
How often does this machine catch an error that you find that you still have to like correct the process? At this point?
At this point, very rarely, but we're not going to stop doing it.
Oh, yeah.
Yeah, so again, it depends on the board. Like this board that's being run now, it's a very basic board. It's large components. When we're making DAC modules and other boards, they're really small components. It's going to catch more errors. Errors happen, but what we like to do is we catch them before they even get tested. So like our last time we ran prime DAC modules, was 99.8% yield, which is insane. Like 99.8% before it went through testing. And then the 0.1 we fixed. And then the other ones, like sometimes there's just part failures because we're placing like, 50, 75,000 parts. There's gonna be failures that are out of our control. So basically all what prevented us from achieving 100 was not this process. It was literally components. So the last thing in here is this machine. It's basically a glorified dishwasher, but this is for washing the circuit boards. Technically, our process does not need to be washed, but we wash all our boards anyways, and we do it for extending the lifespan of our products. So circuit boards go in here, and it washes all the flux off. Even if you use no clean flux, the flux is still slightly active, and we care about how long can our products get used. We care about what's happening, are they still going to be in use in 20 years? So it's a very simple step. We wash the circuit boards, that removes the flux. Therefore, there is no more flux activity on the boards.
What do you wash it with? What do you wash it?
It's a closed loop DI system. So it's DI water with its own filtration system. So, it just circulates completely closed loop.
Do you at a time or just one at a time?
No, we can fill that machine up. So we do a batch at a time. And again, it depends on the size of the board. Like our big motherboards, we do like 6 or 7 at a time. The small boards, we can stick 30 or 40 in. So. With our Kanban system, it's 100% based on orders. Sometimes we're doing 3 or 4 builds of a product a year. Sometimes we do 1 or 2, depending on what it is. Our happy build size is 100 units. So when we do a build, we like to build 100 at a time. We might be doing 100 at a time every couple months type of a thing, depending on the product. But we find that handling 100 boards, it's the easiest to handle and, to go through an inventory and components, feed them through the processes, storing and washing them. I don't want to do a build of 1,000 units to have a year's worth of production. Now, like DAC modules, that's a totally different story. Those we do 600, 700 of those at a time because we use multiples per product. But like our Cascade DACs, we build 100 Cascades at a time. So 100 power supplies, 100 motherboards, 100, and as you've seen in our products, they're so modular that to build 100 Cascades, we're actually building 1,000 circuit boards. There's just 10 different boards. Power bases, front control boards, standby boards, preamp board, motherboard, like it's a lot of boards to produce. And again, 100 we found is just the happy medium. We've done builds of like the Select and 200 at a time. you get bogged down because it's just so much volume of circuitry and like boards being stored. They all go on carts, and now we need twice as many carts. Each one of these are trays for boards. This tray holds 25 boards per tray through these processes. Going bigger than 100 is just cumbersome. So the other thing about this room that's unique is we actually poured a brand new concrete floor in here, and this is actually a ESD rated floor. It looks like a generic epoxy floor, but this is actually a ESD floor. So this is an anti-static room through this conductive floor. So I think we're probably the only business in this area with an anti-static floor in it. So then the last process for circuit board assembly is over here, so we can go this way. So this is called a selective solder machine. This is for our through-hole components. So right now, what's happening is the boards are coming off of the line in the surface mount department, and then they come over here. So here's a board after inspection. As I said, each one has a QR code that has its build information and the number. The solder has been soldered, it's been inspected, and then it comes over here. And then over here, we install the through-hole components. So right now, we have to do it in stages. We're doing the bottom devices first, so it's just these transistors here. And what it does is it goes through, and normally for through-hole processes, you would use a process called a wave solder machine, which is basically it's what it sounds like. It's a wave of solder that you pass the entire circuit board over. We don't do that because we don't want to cover the whole board with solder unnecessarily. Also, it's much harder to do it for double-sided assembly. We have through-hole parts on the bottom and through-hole parts on the top. So what we can do is we can go through here, we install the parts, and as you can see, these are now soldered. The parts get installed, they get placed by hand. They get placed into this machine here, and what this does is, as you can see, there's a little camera view here. This is a jet of solder, so it's just a little tiny solder wave, and it can go through and it can solder the pins one pin at a time, or we can drag it across a row of pins for connectors or capacitors. So the board goes in, you load the tray in, you push the button, and then it goes through and it applies flux to where it's soldering, and then it goes through and applies solder to wherever we program. Programming this machine is incredibly basic. You just load a picture of the board and it's like using paint. You drag colors where you want it to solder. So right now it's going through, it's applying the flux, then it goes to the back of the machine. It has a preheat stage where it activates the flux, then it brings it forward and does the individual soldering. So right here, as you can see, it's going through and it's dragging the solder across the pins. The advantage of this machine versus doing it by hand is it never gets tired and it doesn't miss a pin. It's consistent. It's as good as the programming. So I program this, and we can program it to never miss a step. The other nice thing is, again, it has a nitrogen behind this wall. There's the nitrogen generator. It's all done in an oxygen inert environment, so the solder doesn't get oxidized as it cools. But it's going through, it solders these devices. Then after the bottom's done, we flip the board over. We'd stick in all the capacitors and everything else. Then it goes through and does one pin at a time. Since it's programmable, we can also program how long it solders depending on the size of the pin. So again, nothing is overheated, because this process, the solder here is at 279 degrees Celsius. A soldering iron tip is like 500 degrees Celsius. If you hold the soldering iron on a pin too long, you can actually damage the circuit board. We've seen it where it separates the fiberglass layers because it got overheated. This process can't overheat it. It's a continuous flow of solder, and it's done. So it went in, we went through, and these devices are now soldered. And there it is. Each one's been soldered, and on to the next one. So the next process is it does all the parts on the top, but we, again, do it a batch at a time, and this is why we like to keep our builds at around 100. It's time. So this machine has been incredible. They advertise it as being able to do the work of 8 trained soldering people. We do have a professional trained person for soldering. But we got this because our one person doing through-hole work just could not keep up. And this was years ago. Now there's not a chance they could keep up. And it's really hard finding people that actually know how to do skilled hand work. Pretty much every person we've ever hired, we've had to train ourselves. But it was just for reliability. All our investment in automation that you'll see throughout the building, especially in the machine shop, none of it actually replaced the person. We did it all to use people for what they're good at. People are good at problem solving and doing technical things. We don't want people just sitting there pushing buttons and doing remedial work. This is our laser engraver. We use it for so many different things. In the past, we used the laser marker products with the name and serial number. Now we engrave them all. But we use it for cutting out display masks and stencils and jigs and fixtures. It's been an incredible tool over the years. So I think that's it for this section. Yeah?
Do you do any hand soldering at all, or is it all just done?
Oh, no, we still do hand soldering. There's some things that we just can't use this for. They're too close, the pins are too tight, or the pins are too close to other components. The majority is now done with this, but like in our clocks, it's all hand work. So just for the fact that the parts are so close to each other that you can't take this big nozzle in and solder individual pins. So, and then after this process, we wash the boards again to remove any flux residue. It is a no clean process, but we got special water soluble flux to wash it just because we want to extend the life of our products. So.
Transistors come with their pins pre-bent?
They do not. On another desk, we have a part trimmer. So you just drag the parts across and it cuts the pins to the exact length. And then, depending on the part, we machined our own little bending jigs. So you stick the transistor on and you bend it over. So, there's one installed right there. Perfect bend, same spot every time. The transistors are the only things like this that we have to actually bend. Everything else just goes straight in. So we automate, we use our lead trimmer to trim them to the exact length, then they go in. And then some of the products, like especially if it's AC components, like transformers and the AC connectors, after this we go through and we hand trim them to make sure we meet creepage for AC safety. So.
So does someone have to place all of your bowl parts?
Yes.
You don't have an automated machine that does that as well?
I mean, you can buy machines that do that. Again, our volume doesn't justify, because it's another machine like that, and it doesn't justify because somebody still has to load it. See, with the surface mount things, you can't do that by hand. I mean, I've done it, but reliably you cannot do that by hand. It's impossible. The parts are smaller than a grain of rice, and you're placing hundreds of thousands of them. These you can reliably insert by hand. So, the time it would take somebody to load the machine, program it, bend all the parts, we can just do it. Because those machines only place it, they still don't solder it, so you still have to take it from there and load it in here. Any other questions about any of the processes?
All right, shall we move to the machine shop?
So Daniel will take you to the machine shop. That's kind of his baby.
All right, we're going to head over to the machine shop. Jonathan and Dustin do electrical, and I do mechanical. So the machine shop is really my baby. I love it. We have a lot of really cool toys, and I want to share them with you guys. Let's go. All right, so we'll start here. This is our lathe. The lathe is used to make round parts. So knobs, buttons, feet. We put in a 3-foot bar, and this runs fully automated. So we added a robot tending machine, which will pull out each part as it's finished. And in here, it will wash and dry the part and then place it in this tray. So one of the benefits of this kind of automation is it keeps track of the order of parts. So in a lot of shops, it'll just drop it off in a bin and you'll have a big collection. You find an error and you don't know which ones have the error or which ones don't. You can't track it down to a specific point. So this is nearly perfect error catching because you can find the transition, discard what is bad, keep what is good. Other benefits of automation like this is it saves us from back-breaking work. Automation is often vilified as taking away our jobs, and we are strong advocates for automation because it takes away the worst jobs possible. So a lot of parts we run will have a 1-minute runtime. So the person would have to stand here, open the door, pull out a part, close the door, press go, and have 1 minute to wait. So you can't leave, you can't go to the bathroom. You know, it's like you're just beholden to a machine and you're not learning anything. You're not developing a skill. So this robot replaces an entire day's work and night because it can run in the evenings, and no one has to do this really boring job. So for us, it's a win-win on all counts. So now our operator can do the complicated setup, you know, the high value work, press go and walk away and work on another project or machine, or go work in production for the day. Really, really nice to have these kind of systems in place. So we have more automation in the shop that we'll also show you. But here, the robot will be pulling out a foot. You can come in if you want to get a better shot. So this is right now running the cascade foot. And it's going to keep running while it processes this part. So right now it's doing the wash cycle.
Someone put those eyes on it.
Yeah.
Yeah, I was gonna say, are those,
I mean, all robots have a name and personality, so this one's named Steve. So the part has now been dried. And the robot is now going to prepare itself for the next part. So now we've put this part in our tray. There's no blemishes on it. It's not hit another part. There's no collisions. We have a plastic insert on the gripper that picks it up. So you have a perfect part, sorted, counted, inventoried, all automated. And this is really why manufacturing in California works. It's a really hard market to compete in when you're making it with our real estate values and labor costs. So this is the kind of stuff that really makes us stay cost competitive worldwide. All right, and so now we're going to move on to our next automated machine, and this one is our Grobe. This is a massive CNC. It's a horizontal 5-axis mill with a 20 pallet pool station. So come on over and we'll take a look at what that means. So this is the pallet pool. This is storing 20 different jobs all at once. So if you look in here, you're going to see a Cascade power base and then a Cascade power base. This one is not done. This one is done. So we store up jobs and the robot automatically loads them in, cuts them, and then puts them back. So it does it without any interaction. So our staff can come in and can work for a couple hours, restock the machine, take care of the maintenance, and then they can leave. And it'll run for 30 hours, unattended. No intervention. This is the kind of thing that makes this work. We're able to make these beautiful unibody chassis with the best finishes in the market on one of the most expensive CNCs, and it works because we don't have to have 6 people making it work. And that is, one of MSB's really great value propositions in product design.
So you buy a big hunk of aluminum stock?
Yep, so you can see here, this is Cascade metal. So we have pallets and pallets of this just processed.
So you haven't cut to...
Yep, we have them cut to size out of house because we don't have the space for the big sawing machines. And we get through basically one Cascade system a day because we have the setup for one Cascade. But every day it produces it. Fridays, Saturdays, it'll run into the weekend, just keeps making product constantly. And if someone leaves, it keeps going, which is why it's really, really cool.
I don't know why, I'm interested, but just when you hollow it out, does that scrap get recycled?
It does. So behind you, you'll see here, this is a bin going out of aluminum, that blue bin. So that's an entire dumpster full. All that aluminum will get recycled. Most of the aluminum we use is recycled, and most aluminum ever made is still in use today. Aluminum is very, very recyclable, and it's a great material, especially for this kind of work. Another reason the unibodies are so good and valuable in product design and manufacturing is this is one piece. So if we made a box of many panels, you have to then handle all of these pieces, load them into the machines, and hit go. That is cost of labor versus cost of material. So we get a better product, and it's a lot less work to make a unibody. So we do a lot of manufacturing-related design to make things, again, cost-effective as possible, but also yielding the best possible product. So if you come around this way, Sandra, would you go ahead and pull up a part? So we'll try to, if you gather around, you can see.
On your pallet change, or?
Oh yeah, that'd be great. Bring the camera over this way so you can see. So we're gonna pull out a discrete DAC, it looks like, that just got machined. And this center column robot picks up these pallets and moves them.
So this thing on the left is just like the carousel where you store them?
Yep.
That's the machine over here that actually...
Yep. So now the machine is washing down the chamber, getting rid of any chips that might have been on the interface. So with automation, managing the systems is the most important thing to make it work well. So this company is very good about putting a lot of checks to make sure we don't have any problems, because if it has an issue while we're not here, it won't continue to run. So it does a lot of stuff like that to really improve the workflow and make it efficient. So this,
like a keyboard jukebox over here.
yep, picking up the different plates and serving them. It's again one of these dedicated robots, very effective at what it does. But yeah, this runs 30 plus hours all on its own. Really, really a remarkable machine. What it costs to get this installed was about 1.4 million. So you can see down below, we've actually installed I think it was like 30-inch slab. It's very high precision. So it can't be on this kind of concrete because it's so heavy, it'll actually distort the concrete. And as the spindle moves, it'll flex differently and we'll get inaccuracies. So it's on its own dedicated slab just under the cutting area. So this is a horizontal mill with 5 axes. So you can see the part is now on its side. It's able to move and turn the part and access the faceplate, jack panel, and top. It does a lot of operations all at once. It's very good for unibody designs. The spindle is also on its side. So when it machines, all the coolant and chips fall away from the part. Now behind us here, we have a vertical mill. So this is not as advanced, but you can see the spindle is now vertical. So when it machines, some of the chips will actually fall back onto the part. So it's not as good for surface finishes. So we use this for parts that are less critical. So like it's right now running Cascade base metal. It runs like internal modules, brackets, things that are more cumbersome to work around, like as far as the operator goes, longer run time, so we have to do less load in and load outs, but usually the less critical finishes. So I think we got this machine running right here. You can take a look at it running some base metal. So right now it's running the diamond pattern we have on the bottom of the base metal. So you can see here. So this finish here is a ball finish that takes a ball end mill and runs many, many repeated lines in a diamond pattern. So this gives the metal a nice texture that is more damage resistant because you don't have a perfectly flat surface that gets scratched easily. It also looks fantastic. And this is, again, instead of sanding this and bead blasting this, we use a machine to make a nice finish, and that's added value from the machining and less labor. Again, always comes back to reducing labor and increasing machine value in our products. So a lot of our metal will get just allodyne. So allodyne is an electrically conductive surface. Our chassis are anodized and allodyned. So with the chassis, what they do is they plug all the screw holes and interfaces will get masked to allow an allodyne surface, and then they strip that away and then anodize, because anodizing is electrically resistant. Yes, it is an insulator. So if you see a chassis that's been fully anodized without allodyne additions, you can put a screw in that hole and it will not actually conduct electricity. So it's really important for chassis when you're putting metal together to have those interfaces, otherwise your EMI will just go whoop right through those interfaces. So there is a lot of work put into EMI protection, especially in the most recent Cascade DAC. We've done a lot more protection against external noise because there is more and more of that every day. So we're going to come around the back of the Grove here and show you a couple of the maintenance systems that keep this thing running day and night. So what you won't see on a lot of machines is this. It's a paper band filter. So what it's doing is it's actually filtering the coolant constantly with this paper roll. So you can see here what it's doing. It's got all these chips that it's pulling out of the coolant so that the coolant is perfectly clean. So what happens if you don't have one of these is the chip will go back into the coolant tank and build up. And then your reservoir gets smaller the more full it gets. And then it can't run on its own. So these systems really help. Also, for surface finish, a lot of these very fine chips will go into the coolant and go back into the chamber. And then as it lands on the part, the blade will cut it. It's called recutting. And then it'll smear that little chip on the surface of the part. It'll wear out your tool and it'll reduce the surface quality of the part. So this makes better parts, makes less maintenance, saves a lot of time, and fantastic addition. And then here we have our chip bin. This thing, we run so many unibodies, oftentimes you'll just have a trash can for chips, but we make so much chips from these big unibodies that we have a full dumpster. And this conveyor is gonna run those chips out from the cutting chamber constantly. So as it goes up the conveyor belt, the coolant runs down so that you're just getting chips out into this bin. And it's gonna get really tight, but we'll go back around here. So what we have here is, again, another example of how we like to be very extra about manufacturing, where we prioritize quality over everything else and go the extra mile. So this is a Heimer heat shrink system. So in a traditional tool, you'll have a collet and a nut. So it's a mechanical stack up. So you put the tool in, we'll probably have an example here. There we go. So you put the tool here in a collet and have a nut. And as you tighten it, it adds stress and deformation to the steel. And the collet is at a taper, so if it's slightly cockeyed, your tool will have run out. And run out means the tool is not perfectly straight. And as you cut, the tool will wobble side to side. So you'll have like a cut mark, and one will be shallow and one will be deep. One will be shallow, one will be deep. So your surface finish gets irregular. So instead, what we use is a heat shrink system where we use this electromagnetic coil to heat the tool up, put the tool in, and then as it cools, it shrinks. So there's no mechanical stack up. It is a very concentric tool with equal, very distributed pressure on the tool. So there's no deformation from like squeezing a tool, and very tight run out. The tools last longer, especially some of our very expensive tools. The finishes are better. And another unique thing is this is a very narrow approach to the tool. So like you saw that other one with the big bulky nut, it's hard to get that into a lot of places. So the heat shrink allows us to do cooler machining and get into more difficult and tight places like this, yeah. So this is an 1/8 inch end mill, and look at how tiny that tooling is. And if you look closely, there's actually through spindle coolant coming out around that tool. So it blasts coolant right to the very tip. I mean, these are very, very cool. For the machinists out there, we love this kind of nerdy stuff. It's amazing. It's really, really fun. We like to share it with people. I don't know how many people care, but I do. I love it. It's really fun. And then we have an inspection system over here with a Leica microscope where we can look at those tool finishes and see how they're doing. We can do measurements on parts, making sure we're keeping everything in line. This machine is so accurate, it exceeds basically everything we need. But whenever we're trying to troubleshoot, this is a very good way to figure out really, really detailed work, especially when it comes to small end mills that are making patterns that are hard to see with the naked eye. So it's always good to have that. Yeah, so we'll just run this real fast as a demo if you want to bring the camera nice and close. So this tool is already loaded in, and we're going to heat it up. So you can see a little smoke, just like that. So no wrenching on it, no little parts, and we can take the tool out and put it in. It's really, really nice stuff. Very expensive. You know, it's in the highest end shops in the world use this system, but we couldn't resist. All right, and then if you want to look at some tooling, we have a little window down here that shows our tool carousel, where we have many, many tools for very specific applications: drills, end mills, roughers, finishers. We'll see what you can see. So if you look up, this is a gigantic carousel wheel of tools, and so many different types. You'll see a lot of the drills are still in the collet style because the run out matters less for those since they're not doing sidewall finishes, and the drills get pre-started and are self-centering. And then here you can just take a look at some of the things that we do.
What are these for?
So these are heat sinks.
Okay.
They don't go all the way through because this is only operation 1. Then we'll flip it and do the second operation. But you can see where a unibody makes sense. It does a lot of added value. So we have our transformer pockets with the studs for mounting the transformers, the grounding screws, the shielding screw. We add and put in a serial number. The volume or the power control is integrated. The grounding is put over here. All of the machining of the labeling is all done. And again, we put this block in and hit go, and the machine can do all of this work every time, reliably, perfectly for us. So we are, it's really cool to see how a machine can add so much value all at once with more of a front-loaded, research and development and a lot of setup, but the finished good is incredible compared to doing it all by hand.
How long did this take for the machine to do this?
So these are about, I think, 4 hours a side. So probably like 6 or 7 hours for an entire chassis. And then we have, 3 chassis per DAC. So it does add up. But with this thing running 24 hours a day, really, really plows through the metal.
Who does the design to originally make this so the machine can do it?
I do all the design myself. Yep. So I do all the layout, mechanical design, all the interfaces, and then Sondriel, who was around here, he's the one who does the camming. So I used to do all the cam work myself, except this stuff got way too complicated, spending way too much time in the shop, and then we hired him as a machinist to do that work. But I started working at MSB about 10 years ago, or 12, 14, 15, something like that. And my first project was to buy a machine. I bought a mini mill. It was like $35,000. It was a very bad machine. And I learned how to program and machine myself all from YouTube. We went from there to this, and I got us pretty far. But like I was just doing it as, you know, just a fun thing to do. But we saw the value in it, and then we reinvested everything we had in these very nice machines for it. But you know, it's just doing this in-house is just like the number of features that we were able to integrate is so cool to us because we are nerds and engineers, and to add that is just really fun. Because until you do the actual manufacturing of it, you don't get a sense for how to design in a way that is efficient and also, you know, feature rich. So yeah, we can get some closer shots of this chassis here. And feel free to take a look, but yeah. Sondriel, could you bring down a input module palette or a remote palette or something with?
Remote palette. It
Okay.
doesn't have anything on it.
Do you have anything with inputs then?
Negative.
Just bring an input module palette then.
Machine is a programmer or person around full time?
Yeah, that's this guy,
Okay.
Sondriel. Yeah, there's a lot of programming.
That's nice to push the button when it
Just push the button, the machine does it all for you.
There you go. Yeah, that's it.
Here's another way that we increase productivity. This is a palette for input modules. So if you've seen our input modules, you'll recognize the shape. So we start with these billet blocks. This is an extrusion. So you can see the smear marks on the outside where it was extruded, and then it's saw cut. So it's a very good way to get material to a specific size. And then speaking of like designing for the material, instead of choosing an arbitrary module size, we chose based on the material. So we developed the module to fit in this geometry. So then these come on this pallet here. Yeah, so they just heat up a big like crucible of the material and then extrude it out. Yeah, it's like a spaghetti maker basically. So we put 5 of these on here and then run the pallet. It does the first operation, and then after that it flips over into the second operation. So it's universal for the modules. So if we run USB modules or renderer modules, they all go into the same profile. We have all the programs preloaded. It makes us very good at lead times. So unlike many shops or companies where you place an order at your local machine shop and they have to get the material, do the setup, make this first sample and send you the parts, I can walk out here in one day, design a new module, program it, and run it, and it's already set up. We don't even have to do setup for it. We just update the code, hit go, and then I've got a prototype of a physical product that's basically ready for finish. So that's a really unique thing about having these in-house. A lot of the products we've designed within a week, the mechanical enclosures, and have physical product to test with and improve upon. All right, and so I think that concludes the machine shop tour. Yeah. Oh, and one other note before we conclude. So the finishes on this machine are the first time we've had finish quality that is good enough that bead blast covers like any machine lines. So the Cascade DAC has no hand sanding, no hand finishing. It's just bead blasted, anodized, and is ready to go under a light for inspection and has no machine lines coming through. In the past, when you have lower tolerance machines, you'd have to hand sand with an orbital sander out all of these finishes. So you'll see a setup on the far end of the room for that. We used to have 4 of them, 4 setups where people were manually sitting here sanding parts and making them hand finished. But this machine replaced all of that unnecessary work and provides a better product because you don't have the variability of a hand sanded finish, and very, very happy with it. And now I think that concludes our machine shop tour. Does anyone have any specific questions about this setup or? We want to say thank you guys for visiting. It was our pleasure to have the Audiophile Foundation here. It's really fun for us to share what we do. We're very passionate about it, and hope all of those watching get to see those fun toys and see what we're about. Yeah, thank you so much. We're going to do some listening and just kind of enjoy and talk and discuss some of our technologies with you guys. And yeah, thanks for visiting.
Thanks for visiting.
Thank you.
Do you need to sit here?